This is our engineering group. We're the Egyptian Space Agency. We have Tyler as our verification manager, myself, Luke, as the project manager, Joshua as the test manager, and Tyson as the construction manager. This is our NASA Mars Lander final report. In this presentation, we'll go over the introductions, background, requirements, final design, manufacturing activity, test results, and conclusion. So this is our request for proposal. We have been selected by a contractor to design a Mars lander for NASA, and we're supposed to deliver astronauts to the surface of Mars. We are competing against other potential contractors over a multi-million-dollar bid. We have to demonstrate our completed vehicle today. We've provided a list of materials that we use to design our vessel. There are 2 pilots, and they're eggs, and they cannot eject from the craft. And the craft itself cannot have no visible damage to the pilot after each test drop. We'll be doing 2 test drops, and our vessel has to be reusable. And this is our 15-minute video report. So phase 1 summary, customer requirements, documents. The Mars lander shall deliver astronauts to the surface of Mars, and it will all be demonstrated on launch day with video recordings. Our Mars landers should carry 2 pilots. In this case, they're eggs, and as mentioned, Mars lander has to be reusable. So phase 1 summary, contractor requirement documents. We're supposed to use the lander to deliver astronauts to the surface of Mars. It must survive a 20-foot drop. Our vessel must carry 2 eggs, where each egg gives each. Our vehicle must be reusable and dropped again for a total of 2 drops. The drops will be held indoors, so it does not have to resist wind. There are no size constraints in your vessel. Both eggs have to be in the same vessel, and there will be allowed time to reset the vehicle after each drop.
So this is the final design for our Mars lander. As you can see, there are 4 parachutes in total for the top left of the lander. All the dimensions are labeled for every part in metric. The core of it is a cross shape made out of a pool noodle that is cut in half and just put together. If you look on the bottom pictures, you'll see 2 ellipsoidal objects. Those are balloons. There's 4 balloons in total to suppress the landing, just for extra redundancy. And the parachutes, the plastic bags on the top, act as they both slow the craft down, and they act like fins, providing stability in its descent. Our materials list is as follows. We had 1 pool noodle, 1 square foot of bubble wrap, 8 plastic grocery bags, 20 rubber bands, 20 cotton balls, and 4 balloons. No changes were made to the material list. We did, however, only need to use 4 out of the 8 grocery bags. As you can see right here, we have our materials laid out on the table. Everything is surrounded by a black box with text in the middle to just label each thing, so everything is just labeled there, pretty easy to see. So this is our construction plan. The first step was to cut the noodle in half, and then we make intersecting cuts in the middle. So, like for the center of each, you cut half of the diameter so that they can fit flush to each other. And then you take two sets of two rubber bands and you put them in a crossing pattern. So they're crossing each other and they hold, and you put them on the pool noodle and they hold the center pieces together and they just lock in like that. Step two, on a single pool noodle on the top part, you cut two cavities on the left and right side of the intersection, a little bit bigger for the eggs to fit, so you can put some cotton balls to pad it a bit. And then you cut out part of the caps that you took out so that you can put them back on. Step three, you take those caps that you cut out of the cavity and you tape that to two separate bubble wrap pieces that you cut. So first you have to cut the piece of bubble wrap into two half square foot pieces, and then you tape each cap onto the top of the cap onto the bottom of the bubble wrap. And then for step four, you put the caps on the cockpit section of the pool noodle, and then you wrap the bubble wrap section around that, and then you put two sets of two rubber bands around each part, each part of the bubble wrap, so that you can close it and it stays secure. Step five is you're putting the parachutes on, so you stuff one hand of the plastic bags into there's a divot in like the intersection, and you stuff the one handle into there, and on the other end you tape the handle onto the on the end of the pool noodle. And then step six, you blow up the balloons to halfway of what you would typically blow them up to. And then once you finish blowing them up, you tie the end of each of the balloons shut, and then you tie the end of the balloons to the rubber band in the center. And then step seven is to cut pieces of the leftover pool noodle material that you got from step one, so that they can fit into the caps of the ends of each hole of the pool noodle, so that you can reinforce the tape that's stuck there, and also make the entire structure more stable.
All right, for the continued construction plan, we placed the parachutes strategically on the arms because so that they would fill up with the draft coming over the arms, and that was a good spot to mount them, as it would stabilize the craft as a whole. And then we put bubble wrap over the arms where the cockpit was at. We used that so that for faster unloading and loading of the pilots. And then we had balloons tied to the rubber bands instead of tape them. We had them tied to the rubber bands that helped secure the craft itself in the cross section. So we just had them tied to the rubber bands themselves, and then we pulled the balloons around the entire object and had them so they stick out of the bottom of the craft. And the only real challenge was that it was difficult for all of us to work on the Mars lander all at once, because as Tyson was cutting the pool noodle and putting it together, we didn't really have a lot of space to get all of our hands in there. So it was difficult for all of us to work on it at the same time. And if we were to change anything, we would all designate different roles for us to do it separately, and then put the Mars lander together after that. The left is a front view, in the middle is a top view, and on the right is a side view. It's symmetrical on the x-axis, so the front view and the side view look alike, but the top view, you can see the grocery bags there that are mounted on the arms. On the front and side view, you can see the balloons, how they're pulled up under the Mars lander itself for a soft impact with the floor. And then you can see the grocery bags in the middle picture, kind of a little bit inflated, but obviously not to its full capacity.
All right, and then this is our DD250 that we filled out after our testing, and we're team 8. The test date was April 18th, 2023, and the test location was the FAMU FSU College of Engineering. Our launch height was 20 feet, but we eventually worked our way up to the 3rd story drop and survived that as well. Our original condition, our length was 60.96 centimeters, our width was 60.96 centimeters, and then our height was 57 centimeters. And then we recorded our first load time, and that was 25 seconds. And then we did our first drop, and we survived with no cracks or damage to the eggs. And then after that, we took our measurements again, and we had the same exact measurements, and there was no visible damage to the Mars lander. And then we recorded our unload time, and that was 13 seconds. And then we loaded them back up for our second drop, and that took 24 seconds. And then after that drop, there was still no visible damage to the Mars lander or to the eggs. And our Mars lander had the same exact measurements again. And then this time, our unload time only took 7 seconds. Here are the videos of us dropping our lander for each run. You can see that both times, almost immediately after he dropped it, the plastic bags deployed and they acted as like parachutes coming down. They helped stabilize the lander, and they also helped resist the wind so that it slowly descended down. Also, you can see that the balloons on the lander helped cushion its impact with the ground, and that definitely helped keep the eggs inside stay safe. And then all of this was supported by the 2 beams of pool noodles that were crossed together. So it made it a very stable and wind-resistant object. And here is the bonus drop that we did. This was off the 3rd floor of the FAMU FSU College of Engineering building, and we survived this drop as well. As you can tell, this one kind of it has a longer fall, so it gives you a bigger opportunity to see the bags acting as parachutes and the balloons acting as like a protectant once it hits the ground. And yeah, I think that we performed very well on this, and there was no damage at all to either of the eggs. So here are the pictures after our first 2 drops from the 20 feet. And in both drops, you can tell that once it lands, it just sits on those balloons and it acts as like a cushion once it hits the ground. And then the bags just kind of float, fall off to the side. And then we can just reposition them, take out the egg from the bubble wrap, and then reinsert the egg when we get back up there again.
Conclusions, comments, and takeaways. Our team accomplished designing a vessel made of pool noodles that created a cross shape with beams softening the landing. We used grocery bags as parachutes to create drag and make our descent slower. The pool noodles were set up in a cross shape where then it's assembled with pockets for the beds to be held. We attached balloons and grocery bags to the pool noodles. We held the pilots in place using bubble wrap and rubber bands with the pool noodle cap was discussed earlier. We survived all the test drops with no pilots being harmed, and no rework or redesign was really needed since our vessel was still perfectly fine. And that sums up the Egyptian Space Agency.